Here we are given some information about the triangle ABC, and we are asked to find an approximation to the angle alpha. To do this, we are going to use the law of cosines. To use the law of cosines, you need either 3 sides of the triangle or 2 sides and the angle that the 2 sides form, or the angle that is in between them. Here we see that we are given A equals 6, B equals 15, and C equals 16. So here we have the 3 sides of the triangle, which means that we can use the law of cosines to approximate alpha. Here is the formula that we are going to use. Note that the law of cosines is written in 3 different equations, but the relationship that the law of cosines represents can be generalized in one equation. All you need to remember is that the angle you are trying to find, or the angle that you are given, will appear here in the cosine, and then the side opposite this angle will appear on the other side of the equation, and only here. So we see that we have alpha here as an argument in the cosine, and the side opposite alpha, which is A, appears only on this side of the equation. And the same is true if we wanted to find the angle beta. If we had cosine of beta here, then the side opposite beta, which is B, would appear only here, and the equation would read b squared equals a squared plus c squared minus 2ac times cosine of beta. Well, now that we have the correct equation, we can substitute the values for a, b, and c that we were given into the equation. We have a equals 6, b equals 15, and c equals 16. Simplifying this equation and isolating cosine of alpha, we find that cosine of alpha is approximately 0.927, and then to solve for alpha, we're going to need to use the inverse cosine. So we will have alpha is approximately the inverse cosine of 0.927, and using a calculator to evaluate this, we have that alpha is approximately 22 degrees.